anything about games, so it's so today I just really want to talk about some general ideas and practices that we use in making generative language bots on Twitter. And I want those general ideas to sort of be applicable to other things. Like if you're not interested in language, maybe you can take them and apply them somewhere else. So there aren't going to be a lot of technical details in this talk. I'm not going to go into fancy natural language processing tricks or anything like that. This is really going to be pretty high level. So with that said, a couple questions that I'd like people to bear in mind during this talk are, what are some methods used in simple language generation? That's the one that I have to bear in mind because that's the one that I'm trying to answer. But the second kind of more interesting question to me that I don't have an answer to is, how could these methods be adapted for other mediums? Because I love using them for language, but I really have no idea how you would apply them to something else like images, say, or level design, something like that. So I think it'd be really interesting if people could take these ideas and transfer them. Right, so I generate text with Twitter bots, and for people who don't make Twitter bots, you might wonder why we do that. So this is just a brief slide on why would we do that. And one of the reasons I think is that tweets are a really nice medium for generating language because you have this 140 character constraint. So you don't have a lot of room to mess up, and you're going to mess up, but they're a forgiving medium, and they're short, so you don't have to worry about like, ooh, I have to keep this coherent over a whole paragraph. That said, there's a whole other side of the spectrum where if you want, you can generate, say, 50,000 words for NanoGenmo. That's a totally different thing and also really fun. But yeah, different kinds of language generation. And the second bullet point on here is constancy. I couldn't think of a better word than that. But what I was trying to say with this is that a Twitter bot is like always running. Okay, I said a Twitter bot never sleeps. Some people program their bots to, not say anything for 8 hours. But different from just writing a tool that can generate text and, you push a button and it generates something new. Like you can sit there and push the button and generate something new, and that stops being interesting after you push the button. Whereas a Twitter bot can take an algorithm that you wrote for generating something and just keep doing it over and over. And it kind of keeps it interesting because it can just pop up in your feed and you can see it and then you can forget about it and then it can pop up again. So that's kind of neat. And finally, there's also just this ability to interact with bots. And I was a little bit wary putting this on the slide because most Twitter bots aren't designed as chat bots. They're really just designed to tweet some kind of language, or in the context of this talk, I'm talking about language. Of course, there are Twitter bots that tweet lots of other things. But there is this opportunity for bots and humans, or bots and bots, to kind of quote unquote talk to one another on Twitter. And some really interesting interactions can arise from that because we as humans really like to make things connect and fill in the blanks, and kind of create narratives out of things where there might be a bot that doesn't understand what it's saying, but we put meaning into that. So that's interesting. So those are some reasons that you might want to make bots if you're not making bots on Twitter. But anyway, like I said, this is going to be sort of not just about bots, but also just about generating in general. So I thought about what makes a generative language bot, and one way to break it down is that there are two ingredients, and one of them is the lexicon, or just the most basic elements that you're using to generate things. And then the other is the grammar, or the rules that connect these elements together. How do you put words together, for instance? How do you put phrases together? And in order to make a bot, you need to create a lexicon and a grammar. And one way to do this is to hand engineer it. And Cheap Bots Done Quick is a really, really cool, accessible way to do this. You just define a list of words, and then you can define a list of rules where those words can be inserted, essentially templates on top of templates on top of templates. And that's cool because it really provides a way for people who like maybe have no programming experience to get their hands dirty with creating these things. But one thing that's a little bit unfortunate is that they're kind of difficult to scale because you have to write everything by hand. So really what I want to talk about is how would you make a lexicon or a grammar where you don't have to hand define everything. You instead use things which you found somewhere. So yeah, obtaining a lexicon and grammar. So one thing that's nice about language is that it has inherent structure and we can use that to our advantage. And I would like to argue that you can use it to get found procedural elements. So instead of writing down all of the words that you would want to use in Twitterbot or even getting a predefined list, you can look for those things and put them into your algorithm for generating text. So yeah, why would you want to do this? So like I said, I wanted to avoid using a buzzword, so that's why there's a ... in front of it, but you have better scalability if you're say mining a lexicon versus hand defining it. So there's greater variety in the input, and that leads to more potential surprises in the output. Of course, this is a double-edged sword. You want to be careful because you don't want surprises that are bad. You don't want language that doesn't reflect the intent that you had in making this bot, say, for instance. I think that bot creators are pretty much responsible for the things that their bots say. And any sort of procedural generation algorithm, the responsibility for what they say is not on them, it's on their creator. So that said, choose your corpus or your source in general wisely. I think there's actually a talk that was given at PROCJAM last year called Units of Meaning, which had some things that were sort of relevant to what I want to touch upon here, which is that the elements that you use when you're generating things can come with all sorts of implicit meanings. And I think that people should really be aware of that when they're generating things, especially with language, because language is tricky stuff. I have no idea how I'm doing on time or if I'm talking really quickly, but I guess I'll just keep going. So if you want to automatically get a lexicon or a grammar, where could you look? So since I've only done this with language, I'll just say where I look with language. One thing that is nice that you can do with language is you can pretty easily deconstruct some source into smaller components. So like a book or a tweet or something like that. So you can use, for instance, natural language processing tools to tag all of the nouns in some tweet or find out the subject of a verb or how certain objects are described. And use that to automatically get a whole bunch of words or a whole bunch of ways that people talk about something. It's also important to me to choose a source with a consistent aesthetic. So I tend to gravitate toward sources that have relatively structured or almost templated language. Things that, I sort of expect a verb phrase to occur here after these words, something like that. Or like words or phrases that appear in particular context. So if someone is talking about a certain subject, like say dogs, then I could find the words that they use to talk about dogs, like what do dogs do? How do they describe dogs? Things like that. Can't believe I'm using dogs instead of cats as an example. Well, here's a cat example though. So here I'm just going to share some examples of found lexicons that I use in some of my bots. And all of these examples are going to be from my bots because I know exactly how they work and I know them well. So it was pretty quick to put these together. But that said, there are lots and lots of other Twitter bots that are using some really interesting found lexicons. So I don't know. I'm not here to toot my own horn. This was just the easiest thing to do. So yeah, this example is from my bot called Story of Glitch, who I created so I could have a cat on the internet because a cat in real life wasn't enough for me, apparently. And all it does is it looks at the Twitter streaming API for tweets that have the phrase, my cat just whatever, any text after my cat just. And there are a few other templates that are there, but that's, kind of an obvious one. And then it takes the thing that occurs in the blank and it styles it as though it's an action that cat is performing. So for this tweet that says, pulls all the candy out of your candy jar right now, this bot is making this tweet because somebody out there on Twitter tweeted, my cat just pulled all the candy out of my candy jar right now, which is, I would really like to know the story behind that. Cats are great. So here's my second example. This is a bot that I made pretty recently, and I'm so-so on its output. It's interesting. It was kind of experimental. Everything's experimental nowadays. So the lexicon for this bot, it has a bunch of predefined templates, but the actual words that it's using, like the nouns and the adjectives here, are words that co-occurred with a set of seed words that I had. So I thought, what are words that are used with the words gentle and soft a lot? And I found a bunch of words that were sort of related. And after a little bit of filtering, because there were some words that occurred in certain fixed phrases a lot, like soft drink. I was getting soft drink in a lot of the early output of this bot. Yeah, I sort of dumped them in as the lexicon for this bot, so it would generate text with a particular flavor without actually hand defining all of these words myself. And yeah, I was pretty pleased with the results as like a first pass at this idea. So these examples are from my most popular bot and another bot, which is pretty popular. I was pretty obsessed with the website WikiHow, which has like crowdsourced instructional advice written by random people and probably a lot of teens on the internet. I love teens. So I was really obsessed with this source because it captures a lot of human knowledge, and I was like, ooh, what if a robot tried to do something with it? So WikiSext has a small set of predefined templates, and it looks at the first steps or the first sentence of each step in a WikiHow article, and it just picks one to put in these templates. And it turns out that they actually work fairly well in this format. And then the advice bot, nice tips bot, something I noticed when I was looking at all these WikiHow articles obsessively, was that a lot of the tips and tricks and warnings at the end of the articles were written in like this really cute, earnest tone. And I was like, oh, wouldn't it be nice if there was a bot that tried to give you advice in like a cute, earnest tone? So once again, I just wrote a few templates and I take a lot of those tips verbatim and put them in the template. And this is, these are both a good example of like both consistency in the voice of the source and also language that tends to be templated. Like people will write instructional articles in a certain way where they'll say, they'll put a command verb at the beginning of the sentence, for instance. So it was really nice data to work with from a language perspective. And this is a bot that I made for my cat, Haku. I thought, well, he's very special and nobody's writing songs about him, so I think there should be songs about Haku. And so the found corpus for this bot is song lyrics containing the word you, and I just take the word you and replace it with haku, because generally that keeps the rhyming working. And it's always broken because I didn't program it very well, and the last.fm API doesn't like me very much. But when it works, it's cute and I like it. And yeah, the only thing that this bot does is just, replace the word and tries to intelligently like change verbs and things, but it's pretty simple, and essentially the corpus comes from what are lyrics of songs that I've been listening to lately. So this is something that I sort of elided earlier, but I just want to say something about lexicons. They can be comprised of elements that are positive space elements or negative space elements. So I think when people hear lexicon a lot of the time, they'll think, oh, words, like small things that you put together. And these are an example of positive space elements, where you're taking smaller things and you, say, glue them together with a template. But it's also possible to have sort of these negative space elements, like the song lyrics, for instance, where really you're starting out with a larger thing, and then you're removing a piece of it, and then doing something with it. And either of these can comprise a found lexicon, not just one or the other. And yeah, just an aside here, so Leonard Richardson at the Bot Ally meetup that happened a few weeks ago in New York City gave a talk called Painting Bots, Carving Bots, and I didn't get to see it, but I heard a lot of people talk about it, and he put the slides online. And he likened bot language to collages, like the things that bots generate are like collages. And he talked about how painting bots sort of use additive techniques, much like the positive space lexicon elements. And carving bots use subtractive techniques. And he said most bots use both of these. So yeah, I think that was I really like the metaphor of these things being collages. Like you're starting out with material that already exists and you're cutting and pasting it together in different ways. And it's something that we see in language a lot, but I'm not sure I've seen it done. Well, of course, I've seen it done with actual visual collages too. But I don't know if I've seen it done generatively with other things. So I think it'd be really interesting to touch upon that space. So at the beginning of the talk, I had on my title slide the thing about generated grammars, and I haven't mentioned anything about that yet. So I'm going to argue, and people may disagree with me on this or not. I think that the techniques of using Markov chains or the techniques used by ebooks bots qualify as generated grammars. And I should probably explain quickly like what a Markov chain is, for instance, before going on. So when you learn a Markov chain, basically you take a bunch of text and you analyze it to see what word will occur, or what are likely words to occur after the previous 2 or 3 words. And I would argue that this is sort of learning a kind of grammar, because you are getting a string of words and you're trying to figure out what word could come after those. So you're learning rules about what words can come after what other words. So I would say, in general, a generated grammar is a method that analyzes some kind of input data that you give it, and then it outputs a model that has rules on how to assemble that data. And those rules are kind of derived from the input data that you gave it in the first place. So there are a few caveats I'm going to throw onto here. So my use of the word grammar here isn't necessarily like a formal grammar. I know a lot of people who would maybe get mad at me for using the word grammar here to describe this, but I mean it as just like a general set of rules kind of thing. Another thing is that lexicon is often married to grammar. So the examples that I gave on the previous slide, say about Markov chains, like they are conditioned on the literal words themselves. And pretty much all of the methods that I could think of go down to the lexicon level, that like they kind of depend on you using a certain lexicon to also have a grammar that's based on that particular lexicon. But I don't think this necessarily has to be the case. You can maybe introduce like different kinds of elements into whatever you're trying to get a grammar out of. Say that you take a bunch of text, and instead of learning a Markov chain on words, you learned a Markov chain on some more general things like parts of speech. This would probably get you something that was pretty weird, but you might learn some patterns and get something out of it. And finally, the last caveat is that an under-constrained grammar will generate a lot of nonsense. So for instance, like you can get a grammar that has the rules of how the English language is constructed, right? But if you take all of those rules, usually when we think, oh, there's so many rules, it means that something's constrained. But in the case of a grammar, the rules are telling you what's allowed, and therefore, the more rules you have, the more things that are allowed. And when you have too many things allowed, it turns out that the space can become under-constrained, and you can generate a lot of nonsense from that. And it may not be what you want to do, but maybe it is. I'm not sure. Maybe it depends on your use case. Okay, I guess I already hit my final slide. So just some conclusions from this. So the point that I wanted to drive home is that we can find lexicons in the wild, and we can learn new grammars. And this is cool because it leads to wider variety and more surprising output. And I put the word organic here with a question mark because, you know, how can a bot make something organic? But I think organic in a bot sense, maybe. Like, I didn't get to see Allison's talk earlier, but I heard that she said some stuff about how you should lean into the glitches of your language, and that's the approach that I love to take, because that generates the most surprising things, and it kind of gives the bot like a personality in a bot sort of way. I really like this metaphor of procedural generation and collages of found elements, because I think that there are all sorts of ways to take little bits of the world and rearrange them in certain ways. And I think there are interesting ways to automatically find bits of the world and create a general algorithm for rearranging them in interesting ways. And once again, I'd just like to, I'd like to know, like, how would you use these methods outside of language? If I've gotten you excited about using them with language, that's really cool. But I hope that people who aren't interested in language maybe got something out of this, and that maybe they can apply these ideas to other domains. Yeah, so that's my talk. I'm thricedotted on Twitter and Gmail, and my cat is named Haku, and that's a picture of him, and he's great. Thanks.
Right. 1 second. I'm actually going to ask you all to clap again in a minute, because I don't think... Right. I think this might... Can you hear me? Can you hear me, Thrice?
Yes, I can now.
And there's no horrible feedback loop. Right, let's have a second round of applause that she can hear now. Excellent. I don't know if that came through. Hopefully it did. It's so hard to present a talk like this because you don't get to feed off the laughter. Like, people were kind of getting all the jokes and really enjoying it, and you kind of got this dead silence. I'm really sorry about that. So do we have any questions that we would like to ask? And I'll get the hilarious amplifier. Any questions for Thrice? If not, I will go and check the stream. Bear with me. Sorry about this. So one of the things that So one of the things that really impressed me about bots like Wikisext and the nice tips was the way that you'd inverted the structure of language, which always struck me as something really difficult. Is it really difficult, or is it quite simple for someone to do if they're kind of a novice at this kind of thing?
I think as long as you can recognize that, say, the thing that made it easy for Wikisext, say, is that even though technically the verb forms are different in the way that they're, well, here's the thing. The verb forms on the surface aren't different from the way that I wanted them to appear in the templates versus the way that they actually appear on WikiHow. So that was probably one of the things that tipped me off on, ooh, this is a good source for this particular thing. That said, messing with language can be easy for a novice when you have a source like that, and it can get pretty hairy and difficult if you're trying to change some things that are fancier than that. So yeah, it's kind of a tough question to answer because it depends on your data, really.
Definitely. I had another question which kind of riffs off. Ooh, sorry, I'm getting weird feedback. Sorry. I had another question which kind of riffs off something which someone else asked earlier on at another talk, which is whether you had any problems when you're using this kind of raw, untamable data. You had any problems with it generating stuff you didn't want it to generate, or that people got offended by, especially Wikisext, which I guess can get very euphemistic, because that's the whole point. So have you ever had any problems with this kind of uncontrollable data, or do you not worry about it, or?
Oh, I worry about it a lot. Actually, Wikisext is one of my less troublesome bots, honestly, maybe because like so much of it is, innuendo-ish anyway. But let's see. Yeah, every single one of my bots has a word filter on it that just looks for any kind of substring that could potentially be a slur and knocks it right out. I've had a few problems with a bot that looks for tweets that have things that are an asterisk. Usually it just takes those tweets and then adds nice to them. This is a thing that a human was doing that I wanted to botify. And I ran into a lot of issues there because people will not just put slurs into messages, but they will put, things that are harder to detect that are still things that I don't want the bot to be tweeting. And in those cases, I will go in and manually delete those tweets or try to find ways of recognizing them by looking for certain words that, may appear in tweets even if they give a lot of false negatives. So yeah, I try to put a lot of thought into what problems could arise with certain data and how to filter it, for sure.
Awesome. Thank you so much. Oh, we do actually have a question. I'm going to attempt to ferry over a mic. Hello.
Hi, guys. In terms of, I know that the talk is pretty high level, but in terms of the tools that you're using, do you actually need to mingle with the Twitter API? Or how hard is it to, from the moment you think of these grammar structures to what the actual bot does?
So the question is how many steps there are between the original structure, or?
Between what they think and and the actual result. Do you have to mingle with the Twitter API? Do you have your own tools made right now?
I'm just going to attempt to repeat the question because I think the microphone isn't very good here. But
I'm having a lot of difficulty hearing.
I'm sorry, yeah. We're in like a big room. We've kind of got these microphones, but they don't really work. So there was a couple of questions, I guess. How many kind of phases and APIs does this stuff go through? Do you have a lot of your own tools? Do you have to mangle the Twitter API itself a lot?
It depends on the bot. Generally, when I'm making a Twitter bot, I try to make it so that there aren't a lot of layers. Like I have maybe a layer for getting the source text, and then I have like a Python file that has all the algorithms that mess with that text in some way, and then I just have a script that posts the the tweets that are generated. Obviously, you could have a much fancier pipeline than that, but because these are, usually projects that I finish within a few hours, like I don't do anything too fancy with them, and it's not really necessary to do anything too fancy with them.
OK, thank you so much, Thrice. Let's thank Thrice one more time.